Okay? And so there's lots of things in quantum mechanics that have no causation. Yeah? And so apparently that's not a problem. So even though it might be a problem for us, it's not a problem for the universe, right? The second one is this is the first law of thermodynamics theory, which says you can't get something for nothing, right? If matter represents energy, and a lot of energy, yes? Okay, E equals mc squared, right? Right, that means that 1 kilogram of matter, if turned into energy, well, that's 3 times 10 to the 8th, right? Squared, it's 9 times 10 to the 16th joules. A kilogram of matter creates 9 times 10 to the 16th joules of energy, right? So if matter represents energy, and a lot of it, right, there's a crazy thing that all gravitational energy is actually negative. It's not energy you have, it's actually energy you would need to put in to separate the objects to infinitely far away. All of it's negative. It's always attractive, like me. Okay? Yeah? Okay? So with charge, you can have positive and negative potential energy, but gravitational, since it's always attractive, is always negative. So it's quite possible that the net energy content of the universe is 0. All the gravitational potential energy, and there's a lot of it, is negative. All of the matter is positive. Yeah? That sort of makes you feel small, doesn't it? Yeah, all of this is really nothing. But it's not, of course, right? Okay. And then the final paradox, and this is the one of infinite regress. This is the world stands on the back of a turtle. Well, what's under the turtle? Well, it's another turtle, right? It's turtles all the way down or something like that, right? This is probably a bedrock paradox, right? And you can insert your deity anywhere here you want, right? But mine goes right here, okay? But basically, if you believe that the Big Bang is a quantum fluctuation of something, right? Of what was it a quantum fluctuation? What was there before? It's like Winnie the Pooh. Do you guys read Winnie the Pooh when you were little? Yeah. Yeah? Okay. Do you remember the one where they go to visit Rabbit? Eventually Pooh goes inside and eats so much honey he can't get out of Rabbit's hole. You remember that? Yeah, that's one of the better stories, right? But when they show up at Rabbit's house, they shout into his house. They go, hello, is anybody home? And Rabbit says, no, nobody's home. Yeah? And Pooh says very wisely, there must be someone home for someone to say that there's no one home. Right? It's the same sort of thing, right? It gets there's very little in philosophy beyond Winnie the Pooh, right? Okay? And I'll stop with this comment here, okay? But the interesting thing, and I think this is interesting, is that there are things, if you look at the universe, okay, there are things that we don't know why they turned out that way. The mass of an electron, the charge of an electron, the mass of a proton, right? And if these things we think that they just settled out randomly, that the way they are, and that they could have settled out differently. Had some of these parameters settled out differently, the matter itself wouldn't have existed. You wouldn't have had any electrons bound to protons. You wouldn't have carbon. You wouldn't have had life, right? So you really can ask this question, and this is something that philosophers talk about, right? You can ask the question, you can say, well, okay, if you want to be totally, atheistic and all there is science, right? Then you could say, well, of course, we're asking the question, many universes have existed, we're asking that question in the only universe that could support life, right? Or you could insert your creator there. Maybe there was, when the Big Bang went bang or something like that, that there was some intelligence behind the way things settled out, right? That the roulette ball didn't fall randomly on the wheel or something like that. But that's far more interesting than, physics or something like that. These are other theories that I'll just mention that Timothy Ferris spends like a whole page talking about out of his, 367 pages or something like that, right? Other theories, there's the tired light theory. People who don't like the Big Bang really don't like that the universe is expanding. Once you recognize that it's expanding, okay, it's pretty hard to deny that it once was smaller than it was, et cetera, right? It all goes from there. And so the tired light theory people say, look, no, the universe isn't expanding. It's just that, because how do we know that it's expanding? Isn't it red-shifted? There's a Doppler shift that's red-shifted, and that means they're moving away, yes? Yeah, right. That's the whole thing, right? What they say is, look, it's not red-shifted because it's traveling away from us. It's red-shifted because it just gets tired, right? And then the Big Bang people say, well, how does it get tired? What's the mechanism? And these guys say, what's the mechanism for the Big Bang to go bang, right? And it's like, I don't know, right? But nobody really, I mean, the problem with this is that it doesn't have any testable predictions, right? Okay. There's the C-field theory, and the C-field theory says that the universe is infinitely old and that matter is just coming into being. It's not very common because the universe is so vast, but matter is just being created randomly in the universe in all places, right? Yeah? Which, you know, who's to say that this theory isn't correct if the Big Bang is correct, because we can't tell you why it went bang, right? Okay? But we have a good idea that it did, right? The only problem with this is that how do you explain things like the cosmic microwave background? I mean, there's all sorts of things, right? This is the theory, but the Big Bang theory has more evidence, so nobody really believes this, right? The plasma model is the idea is that the universe is pulsating. So some parts are expanding, some parts are contracting. It is vast after all, isn't it? Right? So who's to say over there where we can't see it's not actually contracting, right? And over here it'll eventually contract and expand, or who knows, right? But as Timothy Ferris says, with barely hidden sarcasm, it hasn't made any testable predictions. Yeah? That's kind of the kiss of death. If your theory can't make any prediction that can be tested, right? And this is also the downfall of Chris Murrayism, right? You know what Chris Murrayism is? It's the notion that the universe isn't old, like 13.7 billion years. It's not even 6,000 years old. It's actually 49 years old. It was created on the morning of November 1st, 1962. I'll defend this, you know. I'll defend this to the end, right? Okay. And I had somebody say, no, I was born before then. And I go, oh, no. You were created at that instant with memories of a previous life that didn't really happen. Right? World War II, all the bombs buried under, unexploded bombs under London that they keep finding, all of that was created at that time. There were old people created even at that time with memories of World War II. This collective memory was just created, I don't know. You know. Obviously, Chris Murrayism doesn't have any testable theories either, you know, any testable predictions. But thank you for listening to the Big Bang.